Hi students, welcome to physics classes. Today we'll discuss important questions for 1 mark and 2 marks as based on SSC public exams 2022-2023. Physical science, physics, only physics. Some of important 1 mark questions and 2 mark questions we'll discuss. First one is heat. Now convert 25 degrees Celsius into Kelvin scale. 25 degrees Celsius into Kelvin scale. Now whenever they given Celsius and they asked for Kelvin, we should add 273. Whenever they given Celsius and asking for Kelvin, we should add 273. So 25 plus 273 equal to K. Now 298 Kelvins. 298 Kelvins. If they ask Kelvins to Celsius, we should subtract minus 273. We should subtract 273. Kelvin to Celsius, we should subtract 273. For example, they given 300 Kelvins asking for degree Celsius. So minus 273. 300 minus 273 equal to Celsius. Now it is 27 degree Celsius. Okay, next, if two bodies are at same temperature, x degrees Celsius we can take, having contact with each other, then the bodies are in the state of, if two bodies are having same temperature, are in the contact, then heat will not be transferred because both are at same temperature. Heat travel from higher temperature to lower temperature. Higher temperature to the lower temperature. Two bodies at same temperature means heat will not transfer. So they are in a state of thermal equilibrium. Question I'll repeat again. If two bodies are at same temperature and having contact with each other, then the bodies are in the state of thermal equilibrium. Next, what is the relation between joule and calorie? 1 calorie equal to 4.186 joules, or 1 joule equal to 1 by 4.186 calorie. Relation, when they ask relation we should write. Some of the students are writing joule definition and calorie definition separately. If they ask relation, among them relation we should write. Next, what is the relation between temperature and kinetic energy? What is the relation between temperature and kinetic energy? Temperature and kinetic energy both are directly proportional. Absolute temperature is directly proportional to average kinetic energy. Directly proportional. When kinetic energy is more, temperature is more. When kinetic energy is less, temperature is less. Or vice versa. When temperature is more, kinetic energy is more. When temperature is less, kinetic energy is less. Okay. Now, what is the final temperature of mixture of 50 grams of water at 20 degrees Celsius is mixed with 50 grams of water at 40 degrees Celsius. So when they given like this problems, final temperature T equal to M1 T1 plus M2 T2 by M1 plus M2. Now 50 into 20 plus 50 into 40 divided by 50 plus 50. So 50 if you take common, 20 plus 40, 60 by 100. 50 here 2 times cancel. 60 by 2 equal to 30 degrees Celsius. Final temperature is 30 degrees Celsius. Next, define specific heat. Define specific heat. What is the definition for specific heat? It is the amount of heat required to change the temperature of unit mass of the body by unit temperature. Now, if a body of mass 1 gram mass is given to you, So to change its temperature by 1 degree Celsius, its initial temperature onwards, if you change 1 degree Celsius, you should give some amount of heat, no? That is specific heat. Amount of heat required to change the unit mass of the body, change the temperature of unit mass of the body by unit. Amount of heat required to change the temperature of unit mass of the body by unit. Unit means 1. Okay, now what are the formula and units? Specific heat equal to Q by M delta T. Specific heat formula Q by M delta T. SI units joule per kg kelvins, CGS units calorie per gram degree Celsius. Very, very important. This both. Now, specific heat has water has a specific heat 1 calorie per gram degree Celsius. Sometimes they will ask, or they will give this value and they will ask what does it mean. State in brief meaning of water. Specific heat of water is 1 calorie per gram degree Celsius. So here 1 calorie heat energy required to convert 1 gram of water, to change the temperature of 1 gram of water by 1 degree Celsius. 1 gram of water, for 1 gram of water to change the temperature by 1 degree Celsius. For 1 gram water, we want to change 1 degree Celsius temperature. If we want to increase, we should give 1 calorie of heat energy. We should give 1 calorie of heat energy. Next, specific heat of ice is 1 by 2 calorie per gram degree Celsius. So 0.5 or 1 by 2 calorie of heat energy is required to change the temperature of 1 gram of ice by 1 degree Celsius. 0.5 or 1 by 2 calories of heat energy required to convert 1 gram to increase the temperature of 1 gram of ice by 1 degree Celsius. Simply we can say 1 gram of water given to you to change its temperature by 1 degree Celsius. Either you should increase, for example, water is at 40 degrees Celsius. If you want to increase by 1 degree Celsius to get 41 degrees, 1 increased. So we should give 1 calorie of heat energy. The same ice given minus 10 degrees Celsius. We want to raise its temperature by 1 degree Celsius. So minus 9 degrees Celsius. We are increasing 1 degree minus 9 degrees Celsius. So for this we should give heat energy, no? That is 0.5 calories. Very, very important. And we have latent heat. The amount of heat required to change the state of body without changing temperature. It will change the state of the body, but it won't change the temperature. That is latent heat, denoted by letter L. Latent heat of ice is 80 calorie per gram. Latent heat of vapor is 540 calorie per gram. Like here, it will be, what is the meaning of latent heat of ice? Equal to 80 calorie per gram. Vapor also. Latent heat of ice equal to 80 calorie per gram means to convert 1 gram of ice at 0 degrees Celsius to water at 0 degrees Celsius. The amount of heat required is 80 calories. To convert 1 gram of ice at 0 degrees Celsius to water at 0 degrees Celsius, we should give 80 calories of heat energy. That energy is utilized to change the state of the body, not to change the temperature. Latent heat of vapor or steam is 540 calorie per gram, means 1 gram of water at 100 degrees Celsius to vapor at 100 degrees Celsius. The amount of heat required is 540 calories. Amount of heat required is 540 calories. Next question. Now amount of heat directly proportional to mass when temperature is constant. Amount of heat directly proportional to change in temperature when mass is constant. Now the question asks for same mass, the change in temperature, for same mass the change in temperature is dash to amount of heat, directly proportional. For same change in temperature, mass of the body is dash to amount of heat, directly proportional. Okay. Now temperature is the measurement of dash, degree of hotness and coldness. Hotness, coldness. Next, they will give you two statements. Evaporation is a surface phenomena. Evaporation, surface phenomena. Second one, temperature of a system falls during evaporation. Temperature falls during evaporation. Which one is correct? Evaporation is a surface phenomena because surface water molecules get evaporates. And temperature of when evaporation takes place, what about the temperature? We know evaporation is a cooling process. So temperature will fall. Both statements are correct. Okay. Next question. During winters, we'll observe droplets of water in the cricket field, leaves and grass. How are these droplets are formed? During winters, we'll observe water droplets on the cricket field, leaves, grass. Why it is formed? We know that is condensation. Because of condensation, vapor will be converted into liquid form and that will be formed on the window panes, bikes which are placed outside, on the grass and the leaves, okay, on the open area. Okay, that is condensation. Next, does the surrounding air becomes warm or cool when vapor phase of H2O condenses? H2O condenses means vapor to water. Vapor to water. Now, as we know, condensation is a warming process. Warming process. So, surrounding air becomes warm. Surrounding air becomes warm. Okay. Next question. What is humidity? What is humidity? Humidity is the amount of water vapor present in the atmosphere. Water in the form of vapor present in the atmosphere is known as humidity. Next question. What happens to water when wet cloths dry? What happens to the water when wet cloths dry? They will evaporate. Because of evaporation, water becomes evaporate. Next, how much heat energy transferred when 10 grams of water at 50 degrees Celsius boiled to vapor at 100 degrees Celsius? Water at 50 degrees Celsius directly will not convert into vapor. So here we should remember water 50 degrees Celsius to water 100 degrees Celsius we should convert Q1. Next, water 100 degrees Celsius to vapor 100 degrees Celsius we should convert Q2. Water at 50 degrees Celsius to water at 100 degrees Celsius. Q1 equal to temperature changed ms delta T. M is 10 grams. Specific heat of water 1. Change in temperature 50 to 100 is 50. How much? 500 calories. Next, Q2. Temperature not changing, state changing, latent heat ml. Mass 10 grams. Latent heat of vapor 540 calorie per gram. So 5400 calories. Total Q equal to Q1 plus Q2 equal to 5900 calories. Define latent heat of fusion. Latent heat of fusion means latent heat of ice. Amount of heat required to convert 1 gram of ice at 0 degrees Celsius to water at 0 degrees Celsius is known as latent heat of fusion of ice. That is Li is equal to 80 calorie per gram. Okay. Next, they'll give statement. Ice melts at 0 degrees Celsius at STP. Ice melts below 0 degrees Celsius. Ice melts at 0 degrees Celsius is correct. Water is used as a coolant. What is meant by coolant? Which cools the vehicle radiators will pour water. That is, it will cool the vehicle radiator. Temperature will be controlled. Water has more specific heat. So water is used as a coolant. That is A. Next B, they given specific heat of water is high. Yes. Both statements are true and B supports A. Okay. What is the reason for formation of water droplets on the surface of leaves on winter days? Formation of water droplets, that is because of condensation. Condensation. Okay. Next question, what is mean by thermal equilibrium? Starting we discussed one question. Thermal equilibrium. When two bodies are in the contact, if both are having same temperature, heat is not able to exchange, that situation is known as thermal equilibrium. Thermal equilibrium is a state when the body is not able to give heat energy. When a body is not able to give heat energy, not able to take heat energy, neither gives nor receives heat energy, then in that state the body is said to be in thermal equilibrium. The state body is said to be in thermal equilibrium. Okay. Now another question, 1 calorie per gram degree Celsius is the unit CGS unit of specific heat. Now joule per kg Kelvin is SI unit of specific heat. So what is the relation? 1 calorie equal to 4.186, 1 gram equal to 1 by 1000, it will come up 10 power 3, 10 cube. 4.186 into 10 cube joule per kg Kelvin. Next, what are the applications of specific heat? Application of specific heat. Water, oceans delivers large amount of heat. Sun delivers large amount of heat that is absorbed by ocean water, and its temperature will not rise because it has higher specific heat. Next, watermelon. Watermelon, even it take it out from the fridge, it stays more time cooler, that is because it has more specific heat. Next, samosa, even outside it is cool, inside curry will be hot because it stays with more specific heat. What is dew? Dew is the condensed water droplets which are formed on the leaves, window panes, vehicles, whatever is placed outside, that is dew. What is fog? Fog is a mist, thick mist. It appears in the winter mornings, that is fog. Now change of state. Melting, ice to water at 0 degrees Celsius. Freezing, water to ice at 0 degrees Celsius. Boiling, water to vapor at 100 degrees Celsius. These are the change of states which are very important. From the chapter heat, most of the questions we covered. And one more thing we should remember, yesterday in the previous video we seen 8 more questions. Activities we discussed. 4 more questions, 8 more questions, activities we discussed. Compulsory learn materials required to do that activity. So some of the times they are asking 2 more questions and 1 more questions. What are the materials required to do the particular activity? So you can write easily. If you learn 8 mark questions perfectly, that questions you can answer. Most of the questions, at least one question will come. Okay, materials required to do any activity that you should learn. Next topic, refraction of light at plane surfaces. Refraction means when light traveling from one medium to another medium, it changes its path because of change in the speed. Change in the speed of light changes. Due to that, sometimes light ray changes its path, that is known as refraction. We have two types of mediums: denser medium, rarer medium. Denser and rarer. Denser means which has more optical density. Rarer means less optical density. More optical density, less speed. Less optical density, more speed. The medium which has more speed, has less optical density, is known as rarer medium. Less speed, more optical density, known as denser medium. Refractive index is the ratio of speed of light in vacuum to speed of light in medium. This we discussed in the previous video, so I am going brief. Refractive index is the ratio of speed of light in vacuum to speed of light in medium. It is not having any units because it is the ratio of two same physical quantities. Same physical quantities, so no units. Next, relative refractive index. Relative refractive index, N21 equal to N2 by N1 equal to V1 by V2. Reciprocal, remember this. N2 by N1 equal to V1 by V2. Sometimes they'll ask question N21 equal to 1.33. What is V1 by V2? 1.33. Simple question. Okay, suppose they ask N21 equal to 1.33, so V2 by V1, what they ask, you should see 1 by 1.33. Okay, this is N21 equal to N2 by N1, N21 equal to 1 by N12. Relations, very very important. Next question, Snell's law. Write the Snell's law and explain the terms in it. N1 sin I equal to N2 sin R. N1 refractive index of first medium, sin angle of incidence. Refractive index of second medium, sin angle of refraction. When light ray travel from denser medium to rarer medium, angle of refraction is more than angle of incidence. When light ray traveling from rarer medium to denser medium, angle of incidence is more than angle of refraction. What are the laws of refraction? Laws of refraction. First law, incident ray, refracted ray, normal at point of incidence lie on same plane. Second one, sin I by sin R equal to constant or N1 sin I equal to N2 sin R. During refraction, light follows Snell's law. Total internal reflection is a essay question, but remember the definition. Sometimes they can ask for 2 marks also. When light ray traveling from denser medium to rarer medium, when angle of incidence is more than critical angle, light ray reflects into the denser medium. That is total internal reflection. Critical angle. When light ray traveling from denser medium to rarer medium, when particular angle of incidence, refracted ray will not enter. Refracted ray grazes at interface. That angle of incidence is known as critical angle. At critical angle, angle of refraction equal to 90 degrees. Angle of refraction equal to 90 degrees. Now what is the relation between refractive index and critical angle? Sin C equal to 1 by refractive index. Sin C equal to 1 by refractive index. Next, what are the applications of total internal reflection? Application, write any two applications of total internal reflection. Total internal reflection applications: brilliance of diamond, optical fiber. Optical fiber are applications based on the total internal reflection. Now, what is a mirage? Mirage is an optical illusion that appears like a water on the road when we are traveling on the highway roads. When we go there is no water. That is mirage. Next, what is the deviation produced by the glass slab? Like this it will be. Now, what is the deviation? Deviation is 0. What did you observe? There is no deviation. Light ray shifts. That is known as lateral shift. Okay, this is about glass slab and lateral shift. Now some of the questions we can see. Now critical angle equal to critical angle of some material is 45 degrees. Critical angle of some material is 45 degrees. Calculate its refractive index. Now here sin C equal to 1 by refractive index. Now n equal to 1 by sin C. 1 by sin 45, 1 by root 2. It will come up, so root 2. Refractive index is root 2. Next, what happens to ray of light when it travels from one medium to another medium having equal refractive index? When light ray traveling from one medium to another medium, both are having same refractive index, no deviation. Speed of light not changes. Path of light not changes. No deviation. Okay. Now state Fermat's principle. Fermat's principle. Light always chooses a path which takes least time to travel. Least time to travel. Remember, light always chooses a path which takes least time to travel. That is Fermat's principle. Next, one important question: Can a virtual image be photographed? Virtual image be photographed by camera. Can we take photo of virtual image? Can we take? Think. Most of the times we are taking selfie while standing in front of the plane mirror in the dressing rooms. We'll take photo while seeing in the mirror. So, can we take photo of our image in the mirror? Yes. Plane mirror forms virtual image, no? That we are taking photo, no? So, we can take photo of virtual image. Why do stars appear twinkling? Why do stars appear twinkling? Because of atmospheric refraction. Atmospheric refraction. Now the refractive index of a medium is 3 by 2. What is the speed of light in that medium? N equal to C by V. V equal to C by N. C is 3 into 10 power 8. N is they given 3 by 2. Then reciprocal 3 into 10 power 8 into 2 by 3. 3 cancel, 2 into 10 power 8 meter per seconds. On what factors refractive index of a medium depends? On what factors? Wavelength, nature of medium. It depends on wavelength and nature of medium. Next question: suppose you are inside a water pool. You are inside a water pool. Near the edge. You are inside the water pool. Now a friend is standing on the edge. Your friend is standing on the edge. You are inside the water pool. Your friend is standing on the edge. You are here. Now how he will appear? Will he appear taller or shorter? Remember these type of questions when they ask. Now, when you are inside the water, outside person appears taller than actual height. When you are outside, inside person appears shorter than actual height. Now, when you are inside, he will appear taller. When you are outside, the person in the water appears shorter. Okay? When the observer is in the denser medium, the person is in a rarer medium appears taller. When observer is in rarer medium, the person in the water denser medium appears as shorter. Very important.